Alright, in this screencast we're going to learn all about the slope of a line, which is the measure of how steep a line is, whether it's increasing or decreasing. And to get the slope of a line we have to figure out two things, the rise and the run. So let's say we've got this line here, and it's going through this point here at x1, y1, and this other point here at x2, y2. Well, the rise is that change in y, which is y2 minus y1, and the run is this change in x, which is x2 minus x1. Okay, and so we call the slope the rise over the run, which works out to y2 minus y1 over x2 minus x1. So let's find the slope of this segment. All right, so here's my x1, y1, and x2, y2. And so my slope, and we usually use the letter m, don't ask me why, but most books will use m for slope. And I'm going to go 4 minus 1, that's y2 minus y1, over 4 minus 2, that's x2 minus x1. And that gives me 3 over 2. Now what if I decided to make this point x1, y1 and this point x2, y2? Well, let's see what happens. That would be 1 minus 4, because we're going this minus this, over 2 minus 4. And that gives me negative 3 over negative 2, which works out to 3/2 again. So it doesn't matter which point you pick to be x1, y1, and which point to pick for x2, y2. All right, another thing to notice here is that the slope is positive. Notice that as I read this segment from left to right, it's going up. Positive slopes mean you're increasing from left to right. So let's look at this example. I bet you can predict that it will be negative because as we read this from left to right, it's going down. Well, let's see. Okay, I'm going to go 6 minus 1, that's change in y, over 3 minus 9, that's change in x, which works out to 5 over negative 6. Sure enough, it's a negative slope. That means that it's dropping 5 units down for every 6 units it's going across. Well, if I'm given 2 points, I can find the slope of the line that goes through those points just by picking one point to be x1, y1, and the other point to be x2, y2. So let's just do it, okay? So my slope is y2 minus y1, 5 minus 4, over x2 minus x1. Negative 4 minus negative 3. You got to watch your signs on here, guys, okay? And so it's going to be negative 4 plus 3, which is negative 1, and that works out to negative 1. Let's find the slope of the line between these 2 points. So my change in y is going to be negative 4 minus negative 4, and my change in x is going to be negative 3 minus 8. Well, negative 4 minus negative 4 is negative 4 plus 4, which is 0. And 0 over anything is 0. Okay, what does that mean? Well, if we graphed this, okay, we would have a point at, wait a minute, let me change that. I want to put my x-axis up here. There's x, there's y. Okay, so I've got a point at 8, negative 4. 2, 3, 4, there's negative 4. 1, 2, 3, 4, 5, 6, 7, 8. Okay, there's 8, negative 4. And negative 3, negative 4, which is right here. I didn't do a very good job labeling this, did I? Okay, so there's negative 4. And if I draw the line between them, here's what that line looks like. It is a horizontal line. So guess what? If there's no change in y, that means that line is perfectly flat. It is horizontal. Horizontal lines have 0 slope. Okay, let's write that out. Horizontal lines have slope 0. Let's get the slope of the line through these 2 points. So slope is change in y, 9 minus negative 2, over change in x, which is negative 6 minus negative 6, and we get 11 over 6 plus 6, which is 0. Oh, that's a big problem because we can never have 0 in the denominator. What does that mean? It means this slope is undefined. Okay? If we graph these points, okay, so if I go back to 1, 2, 3, 4, 5, 6, and then up to 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, here's the point at negative 6, 9, and negative 6, negative 2, and I draw the line between them. Guess what kind of line we get? We get a vertical line. Every value on that line, every x value on that line is negative 6. So vertical lines have undefined slope or no slope. Okay, that's when the denominator is 0.